Hello everyone, welcome back to our channel. So today we are going to cover linked list problems, linked list cycle. So for those of you who have been following along, you know that we have been diving deep into important stack related questions in our previous videos. So if you have missed those, so please make sure to check them out in our playlist. But today we are shifting gears towards another crucial topic in data structures and algorithms, linked list. So before starting, please don't forget to like this video, subscribe if you haven't already, and let's jump right into the world of linked lists with our linked list cycle problem. So in this problem we have given the head of a linked list, and we have to determine if the linked list has a cycle in it. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to, but this pos is not passed as a parameter. So we have to return true if there is a cycle in a linked list, otherwise we have to return a false. So we have given this example. So in this example you can see that -4 points to the this 2. Okay, so there is a cycle exist in this example, so output is true. Okay, so let's try to write first code, and then I will explain step by step what is happening in the code. Okay, so here in the code, first let's check if our head is null or if there is only a single element in the linked list. So if these are the cases, then we have to just return the false. So this is our first condition. So we are going to check if head is equal to null or head dot next is equal to null. So in this case, if our head is null and there is only a single element in linked list, so if this is true, then we are going to just return false. Okay, so this is first thing. Now after that, we are going to take two pointers, name as slow and one pointer head, fast. List node false, fast. Okay, so we point them both to the head of a linked list. Okay, so now after that what we are going to do, we are going to check if our fast, we are going to check if fast is not equal to null, or if this fast dot next is not equal to null. So if our fast is not equal to null and our fast next element is not equal to null, in that case we are going to move slow dot next, so one step ahead. So if slow moves one step ahead, then fast is going to move two steps. Okay, so we are going to write fast as fast is equal to fast dot next dot next. Okay, so slow moves one step ahead and fast moves one more step ahead of slow. Okay, two steps. Fast is taking two steps and slow is taking only one step. And now in while loop we are going to define one condition, if condition. So if at any point of time fast is equal to slow, so in that case we are just going to return true. Okay, so this is the condition, and in the end we write return one more returns false. So if this is not the case, then we are going to return just false. Okay, so now let's try to run this code. So all the test cases has been accepted. So let me submit it and see the result. So yeah, our code is accepted here and it beats 100% of users with Java. So now let me explain this code with one example. Let me copy it. Okay, so this is our code. So here in the code you see one Java class named solution that contains a method has cycle. So it contains a method has cycle which is used to determine if a linked list has a cycle or not. So this is typically done using the Floyd cycle detection algorithm, and it is also known as tortoise and hare algorithm. Okay, so in this method we take a single argument head. One second, let me. Okay, so in this method we take a single argument head which is a reference to the first node of a linked list. Okay, so that is 3. Okay, so here we are going to check if our linked list first is empty or there is only one single element in a linked list. So in that case we are just going to return false. After that we are going to give two pointers slow and fast, which are initialized to the point at the beginning of a linked list. Okay, then the algorithm enters a loop where the slow pointer advances by one step at a time and the fast pointer advances by 2 steps at a time. Okay, so this is the essence of the tortoise and hare approach. So if the cycle exists in the linked list, the fast pointer will eventually catch up to the slow. Okay, so let me actually, this pointer is not working here. Okay, so let's say first we are going to check whether our linked list is empty or it's just one single element. Then we are going to return false, and after that we created two pointers slow and head. Okay, so both of are these points to this 3 in the starting. Then we are going to check if our fast is not equal to null and then fast dot next is not equal to null. Okay, so in this case you can see fast dot next is 2, so it is not null, and fast is also not null. So in that case we are moving slow one step ahead. So now previously slow was on 3, so now slow becomes 2. Okay, and fast, previously it was 3 and now it moves to 0. Okay, so this is our first step. So in this case slow moves to 2 and fast moves to 0, and now we check if fast is equal to slow, then we are going to return, otherwise we go back into this while condition. Okay, so now fast is not equal to slow yet, so next time we again check whether fast is not equal to null and fast dot next is not equal to null. So now this time fast is 0, so 0 is not equal to null, and 0 next is also not equal to null, -4. Okay, so now slow moves to 0 from 2. Okay, slow moves to 0 from 2, and fast moves to 2 from 0. Okay, okay, so now our fast is 2. Then again in the while loop we are going to check whether fast is not equal to null, and then fast dot next is not equal to null. So in this case also fast is not equal to null, and fast dot next is also not equal to null. So now again we move slow pointer and fast pointer. So now our slow becomes, slow moves to -4 from 0. Okay, 0 to -4, and fast moves from 2 to -4. Okay, so now in this case next we are again going to check whether our fast is not equal to null and fast dot next is not equal to null. So again we are going to follow these steps. Okay, so now after that, now both slow points to -4 and fast also points to -4 in this case. So now again we enter this while loop. So we are going to check fast is not equal to null and this same condition, so that's true as well. So now this time slow moves from -4 to 2, and fast moves from -4 to 0. Okay, now again we are going to check in while loop whether first is not equal to null and then first dot next is not equal to null. So now again slow moves from 2 to 0, from 2 to 0, and fast moves from 0 to 2. Again same steps. Now after that again we are going to check in the while loop whether fast is not equal to null and fast dot next is not equal to null. Now slow moves from 0 to -4, and fast moves from 2 to -4. Okay, so now you can see that we are going to check in this if condition if fast is equal to slow. So that's true. Now both slow points to -4 and fast is also points to this -4 only. Okay, so this condition is true. Then if this condition is true, then we are going to return true. So we are going out of this loop now. So the true is the output. So in this way we are going to solve this question. Okay, so I hope that you guys are able to understand this code. So please don't forget to like, share and subscribe my video. Until then, bye bye and have a great day. Thank you.